Hey, we're back. How's it going, everybody? Wow, there was a lot of people chilling in the live chat before I even started, and not only that, but oh my days, Paul, man, drop in a donation before I even stepped on the stream. Thank you very much for the $4.99, Paul. Massively appreciate that. Just enough to keep your lights buzzing. That's actually funny because before, I would say, about 2 years ago, when I first started doing live streams, I was using halogen lights in here to illuminate the workbench, and you know, those kind of big halogen outdoor lights. And my God, did those things get hot? They absolutely roasted up the place. Didn't even need the heater turned on because they got so hot. And I imagine that they probably were pretty hefty on the electricity bill. But now I'm running LEDs. Come on, man. It's 2020, man. LEDs. Who else has a problem though with LEDs in their house and then trying to freaking film anything? If you're trying to film anything in your house with your phone camera or your DSLR or any kind of camera, and you've got LED lights in your house, that flicker is insane, right? That is one thing that I don't know, I'm gonna have to work out. So we're moving pretty soon. I'm moving into a new place pretty soon, and one of the things that I want to make sure that I have is, because it drives me nuts so much, I definitely need to have full bridge rectified like LEDs that run on DC and don't just take the AC and you know, because obviously it's an LED, so it's only going to illuminate one way. So if you have an LED that just runs on 50 Hertz AC, then it's going to flash one way and then not the other. So it's going to flash 50 times every second. So yeah, 50 Hertz. Which is fine for eyesight and looking. You know, it's not going to flicker to your eyes. But if you try and film anything, then that you know, that frame rate is, that flashing is going to show up in the frame rate. And you're going to get black lines, kind of stuff. You're going to get flickering on the camera. It's really, really annoying. Whereas if you have a full bridge rectified and smoothed power supply little thing inside each of your bulbs, which some of them do have, then they don't flicker like that. They just run on DC, on the rectified DC, which is pretty cool. What's up? What is up, guys? Wow, bare people already. We've got like 82 people already. Oh man, there's a bit of wire stuck in my trousers. There's like a small piece of copper strand, and it gets everywhere. I'm pretty sure it's digging into my leg right now. Really annoying. Brandon, how's it going? Gabrielle, Elliot, Rob, Dr. Krankenstein. Good to see you guys all here. Oh yeah, so yeah, you guys in the States, you're 60 Hertz, aren't you? Vincent, cheers for the 2, buddy. Keep it all full differential and discrete. Yeah, absolutely. Gabriel says you repair only car amplifiers. I repair a few things. I repair car amplifiers, Nintendo Switches, and anything else that I have that's broken. I don't offer any other repair services other than car amplifiers, because car amplifiers are what I know best. If at some point in the future though the car audio scene dies down a bit and there's not enough car amps to repair to maintain my living, then yeah, I'll branch out into offering other repairs as a service. But for now, yeah, it's just the good old car amplifiers, things that tend to die the most often out of pretty much anything else in the electronics industry. Now, gentlemen, you've probably been wondering by the... Oh, ladies and gentlemen, I correct myself. Ladies and gentlemen, you're probably wondering by the title of this video that this video is going to be somewhat regarding an amplifier that is making some strange sounds. Now, if you did manage to catch my most recent live stream, which was actually a couple of days ago now, yesterday I was sleeping because I was absolutely shattered. The day before that was a video. If you caught my last live stream, we looked at a Vibe amplifier. Vibe is a company that we have in the UK here, a manufacturer car audio brand. We looked at a Vibe amplifier, which they call it Class GH, but as someone correctly pointed out, I think there's the only thing really that Class GH itself doesn't exist, but I think Class H is it's like Class AB, but the rails start switching past a certain output level to improve efficiency and get more power from the amplifier. So I guess yeah, it's a Class H amplifier. And yeah, it was making some really interesting sounds on power up. It was a bit like a synthesizer, in fact, which is pretty fun to play around with, but it wasn't obviously supposed to do that. So today we're going to be looking at that one and find out why it's making all these kind of crazy ass sounds. And but just before that, I have something that is a little urgent that I need to just quickly look at. It's not going to take too much time, and that is this B2 audio 4-channel. Let's just shifty Ruby my camera here real quick just to kind of get this a little clearer. Gonna go out and zoom in a touch. Okay. So this is a Rage. This is a Rage 1200.4, as you can see from the bottom of the screen there with the current amplifier, which I have remembered to update on this occasion. I often completely forget to update that. But this amplifier apparently works okay. However, after say 5-10 minutes of it working, of it running, it gets really hot, which is not ideal. So what I'm going to do is we are now going to figure out why this amplifier is overheating at idle or even just playing low volume, and correct that. Now, the customer said that the heat appears to be coming predominantly from the power supply section, which, if I give you the head cam, I'll try not to move around too much with the hat cam. Some people say that it's a little bit sickly. I'll do my best, but I'll just try and keep it still. The power supply section is down here. So we have 4 power supply FETs, push-pull for this transformer, push-pull for this transformer. And so the first thing I want to look at is, I've taken the clamps off, the thermal clamps off the MOSFETs here. I want to take my thermal imaging camera and see whether these heat up on idle, which they absolutely shouldn't do. There should be absolutely no heat coming from the power supply FETs ever on idle. Sometimes output section MOSFETs do heat up on idle, especially in full range amplifiers. In fact, these ones probably will heat up on idle. It's a full range class D, so they're switching quite fast. So there are some switching losses and there is some heat generated by the output FETs in this case, but the power supply FET should stay absolutely stone cold Sauvignon. So we're going to grab the old thermal imaging camera, which has its own issues that I need to address at some point, but we won't do that now. And turn on the power supply. Let's get 12 volts. Actually, tell you what now, let's get like 13 point something volts going in there just for now. I'm only going to allow like 4-5 amps to pass. And let's just check the waves, the wave shape on the scope here. Make sure that the shape of the waves is good, because obviously if it's not good, that'll be heating these FETs up quite considerably. So here we go then. Operation, we have power supply switching. There we go. Well, the output wave looks great. That looks fine. So we don't have any funky output wave of the power supply FETs. Now let's turn our attention to the thermal imaging camera and see what we have going on down here. Okay, there is a little hot spot actually just there. We've got a 47R0, actually a bunch of 47R0s getting pretty toasty down there, 60 degrees in fact. Be interesting to just take note of what they do. They could be pull down resistors, but I can't imagine that the pull down resistors would be that low value. That doesn't quite seem right. I think the pull down resistor is probably this 1000 ohm over here, but we do have considerable heat coming off of these 47 ohms, sorry. 80 degrees now coming off of that. In terms of power supply FETs though, they don't seem to be heating up. They don't particularly seem to be heating up. We've got some heat coming from the output drivers, which is normal. That's absolutely normal to expect that. As they run, there's a bit of heat coming from in the middle there. One of the op amps just working its load there. So we are now at 95 degrees, 97 degrees Celsius on those resistors there. Now let's take a look. What exactly do these have on either side of them? Looks like we have rail voltage. We have rail voltage and whatever the hell that is. Okay. I believe that I think I know what these bad boys are. These are some very funky looking waves that are responsible for generating plus minus VCC. So if we take a look here, we've got some resistors here. Then we've got diodes and capacitors. Now I reckon that these are rectifier diodes and capacitors for... Oh no, sorry, these are Zener diodes. Z2, DZ1 and DZ2. So these are actually Zener diodes. Right, okay, so I think, yes, what we have here then, Q6. We have some we have some voltage regulators. Okay, so this is the auxiliary voltage part of the circuit. Now I don't like the shape of this wave. I like, well, whatever's going on. That doesn't look so great to me, if you ask me. That really doesn't look so great. So let's try and see what we have going on here. Then I'm going to turn the voltage down from 13 volts just to kind of minimize any heat from those resistors there. It's possible that they're supposed to run that hot, but I'm just going to turn the voltage down a bit just to let it run a bit cooler. So we're at about 10 volts now, 9.9, 10 volts. So we've got the waves going in to the transformers here. There we go, looks fine. But what do the waves look like coming out? Okay, so there we have about 13 volts RMS going in. Out here we have 15 volts RMS coming out of the transformer there. And there. Okay, so we've got about a peak to peak of about 15.5-ish, 15.8 volts there. Sorry, 15 up, 15 down. So yeah, we've got about 32 volts peak to peak there from the output of the transformers here. From this transformer, in fact. Actually, hey, this transformer is much lower than the other one. I wonder if that's normal. Perhaps this transformer is supplying VCC voltage for parts of the circuit, and this other one's supplying actual rail voltage for the amplifier. You can see this one here, we have a 31.4 volt RMS output wave from here. Interesting. Although this one here, this tap of the transformer here, this is responsible for the 12 volts reference negative rail. So with a Class D amplifier, as this one is here, and as with many mono amplifiers, the power supply section will consist of the generating the rail voltages for the amplifier to actually work on, that the sine wave swings between top and negative rail. So that's the main thing that it's supplying. But the power supply will also generate a few other voltages for the small chips and parts of the circuit to run on. They don't run on the full rail voltage. They need a much lower voltage to run on. Now in most car amplifiers, you'll find that these lower voltages are actually created by smaller little auxiliary winds on the transformer. So obviously you've got the primary wind on the transformer from the power supply FET, which has a sort of 13-15 volt RMS wave on it. And then on the secondaries, in addition to having the rail voltage taps, you also have the some smaller taps which may generate plus minus 20 volts or plus minus 15 volts, for example, as seems to be the case on this one, but also a very small tap here which generates sort of 15 volts ish, and that actually references on negative rail. So the way that the output drive circuit works is the driver chips, their ground, as far as they're concerned, ground is not 0 volts. They take negative rail as their ground for a multitude of functions to do with low side drive. So for the drivers, okay, these things need 12 volts to work, otherwise they won't work. They need 12 volts worth of power to come on, right? But their ground is negative rail, so therefore they need 12 volts above negative rail, which does look confusing and is confusing at first when you first start looking at car amplifiers. You're like, wow, what the hell? Why is this 12 volt regulator got like negative 80 volts on it? That's definitely not right. Well, it is right, my friend, because actually what you're reading there, the negative rail, is ground as far as that circuit is concerned. And you need to, if it's difficult to use your scope, if you're trying to do maths on the fly and you're trying to do, oh, what the hell was it? Negative 80 plus 12? Oh, that's 68. Okay, so 68 is 12 volts. So you just use your multimeter and just go across the input and output pins of the voltage regulator instead of trying to use your scope for that matter. But yeah, in this one then, let's just go back to this amplifier. So this transformer here, this first one, this one is generating our rail voltages. As we can see there, 31 volt RMS wave coming out of the end of this transformer. This transformer, however, is generating much lower voltage. We have 15 volts plus minus there, which seems interesting. I wouldn't have thought that we'd need such a large transformer here dedicated to just the plus minus 12 volt plus minus 15 volt rails. I would have thought that we would just have a secondary tap coming off of it for that purpose. But yeah, really interesting design there. Now, the shape of those waves, which was on here. Let's take the heatsink off here. Let's take the heatsink clamp off of here. I think these are going to be the voltage regulators, perhaps. Oh no, okay, this is using a different way of regulating voltage. So, which I should have picked out from the Xenodiodes, or the Xenodiodes, as you guys like to say. So over here then, I'll zoom in a touch. Let me just go and zoom in a bit on this this old camera up here. Yep. So what we have here is we have a voltage regulation circuit, which consists of a couple of transistors. Now these are TIP42C and TIP41C, which you can't make out that, but that's what they are. And also what you have down here is you have a Xenodiode, a resistor value, and a capacitor, and some resistors here. Now the combination of this circuit, what this will do is it turns these transistors into voltage regulators. So you can give these transistors, say, 20 volts, and then once you've given them 20 volts, if you then on one of the pins, I think pin 1 or pin 3, you use a Xenodiode to drop a very specific voltage, and you apply that to one of the other pins of the transistor, and then on the final pin of the transistor you will have the voltage, which you are very, very carefully regulating with the Xenodiode, but you'll have it with the amount of current that the transistor can pass. Because obviously the Xenodiode itself can't pass any current, and the Xenodiode circuit can't pass any current. So basically you need to tell the transistor a specific voltage that you want, and then get the transistor to pass that voltage, but with the amount of current that the transistor can pass. So that's a very kind of basic voltage regulator circuit there with using Xenodiodes. But usually you don't get... Usually these amplifiers, they won't be feeding the transistors here with any ripple. Usually they'll just be feeding with DCs. So I'm a bit intrigued as to why we have the funky looking waves on these TIP 42 and 41C transistors. So I'm just going to pull these away from the heatsink ever so slightly. There we go. I just don't want them to be sinking their heat away. I want to see if they heat up or whether it's just the resistors next to them. It seems to just be the resistors, to be honest. These 47 ohm resistors, they are really cooking up a storm. Now let's see what we have over here. I'm interested by this. I'm intrigued by this nonsense we've got on here. Where is that coming from? Now, the customer did claim that this amplifier was overheating, like the heatsink was very hot to the touch. Now, so far, I'm not actually seeing any evidence of any of the heat-sinked components getting hot. I mean, wow, actually, that's a lot of ripple on there. Look, wow. Is this supposed to be the... This looks like another Xenodiode voltage regulator circuit over here. There's a lot of ripple on this one. A lot of ripple on that one. So this is the output switch wave. It's very fast. It's 400 kilohertz. So this bounciness that you see on the top of the waveform, that's pretty normal for a switching frequency this fast. Yeah, that's nothing to worry about here. The rails themselves, positive and negative rail, appear to be pretty smooth. They're not bad. Low side drive looks pretty good. Positive rail looks pretty good. So I would like to see where these voltages are coming from. Like where is that big ass wave coming from? Yeah, I would like to see where this is coming from. That doesn't generally look like anything that I really see very often in car amplifiers, you know, and that 90 degrees operation temperature of these resistors doesn't really seem that common. The thing that I'm a bit confused about though is that, like I say, the customer was claiming that the amplifier was heating up on the heatsink, but so far I'm not experiencing that. I'm only experiencing this these resistors here getting really hot. So with 10 volts worth of input, we already have these resistors at 105, 106, 107, 108 degrees Celsius. Wow. Okay, let's turn her off and let's use the multimeter to do some probing and do some tracing. See exactly where that's coming from, because I can't see exactly where it is originating from there. Okay. Has the rail voltage sunk down to 0 yet? Because we need that to happen before we can start working on the amplifier. Yes, it has, all the way down to 0. Turn the power supply off. Okay, so let's have a look then. This was coming out, I think the largest waveform here was, I think, coming in here. I can't remember, so I've just got to power it one more time. I think the larger waveform is going to be before the resistor. So let's just quickly remind ourselves where the larger wave was, which side it was on. Okay, the larger wave is closest to me on, oh no, there. Okay, the larger wave is furthest from me. Okay, so it's on my left-hand side. Excellent stuff. So we need to probe what is connected to the inputs of these 4 R7s. Not that, that's just a capacitance. Okay, snubber network is this here. This is a 1000 ohm resistor and a small capacitor. I believe that's the snubber network. There's another, actually there's different. There's a snubber network over here for this one. 220 and a capacitor, 220 and a capacitor. And you got 1000 and a capacitor over here. Can't really tell where it's coming from, if I'm honest. There's only limited stuff on this PCB. I don't think there's much on the bottom. I think these PCBs only have components on one side. We could pull it out and have a look. Should we pull the board out and have a look on the other side? See if there are any components on the back side. So I'm slightly confused as to where that is actually coming from. And this 15 volts, let's pull this off here. Let's pull these ones off. Okay, so over here we have two rectifiers, which are D72 and D71. Now these are going to be obviously the rectifiers for the main rail voltage. That's fine, that's connected to these. How interesting. This other transformer over here that only has the 15 volts on it, that appears to also be connected to the rectifier that has the main rail voltage on it as well. So that's a little confusing. Because like I said, I don't tend to see amplifiers that will dedicate a whole transformer to VCC voltages. So as to why I had, look, if I power it up again, as to why we've only got 15 volts RMS on the output of this transformer here, 15.8 volts RMS on the output of this transformer, okay? But on the output of this transformer, we have 31 volts RMS. 31 volts RMS on this transformer, but 15 volts on this transformer, yet they both connect to the same rectifier. They have continuity to the same rectifier anyway. Power supply MOSFETs themselves are not getting warm. Very curious. I am not sure what. So how can we have 15 volts RMS here if it's connected to this over here? That must be connected through something. Must be connected through a wind. And why would this transformer bother stepping up? What's that? 13 volts RMS? Why would it bother stepping 13 volts RMS up to 15.8 volts RMS? Almost seems like no point really. In fact, that's not even. That's 15 volts RMS. So that's plus minus. Let's get a peak to peak reading on here. Voltage RMS, voltage peak to peak. So we have 35 volts peak to peak. Now, where is that getting rectified though? That's the question. This has to be getting rectified somewhere. And it's not getting rectified over here, the main rectifiers, because that has the rail voltage on it. So where is that getting rectified? I think we may have to take the board out and see if there are some other components on the back of this PCB, like other smaller surface mount rectifiers, etc. Because yeah, I think that still looks janky as frick. I think we need to pull this out and have a look on the back of the PCB and see if there's anything we're missing there, because I can't quite work out where the 15 volts from this transformer is being rectified, and I can't see where the voltage for these voltage regulators is coming from either. Okay, let's get this pulled out then, shall we? Just need an Allen key. The funny thing is that the amplifier does work normally. It works absolutely fine, and it doesn't seem to be getting hot either, which is interesting. The customer was saying that the amplifier is overheating on idle. But I mean, you know, those resistors, they're sitting at 100 degrees Celsius. It doesn't really seem normal to me. That's not something that I would consider normal. So this amp has apparently been overheating on idle, even with engine off, 12 volts, you know, 12.8 volts. Additionally, the amplifier is not drawing excessive current either. It's like chilling there at 1.2, 1.5 amps. So I'm struggling to believe that the amplifier, you know, that there's anything overheating really on here. Apart from those resistors, you know, it doesn't look so good. But this amplifier could be working absolutely fine. And I don't know why it would be overheating in the customer's vehicle, but I can't really see any signs of that. But I would like to just pull it apart and just double check and confirm if there's anything on the bottom of the board, because yeah, I don't really trust that so much, how much that's getting hot. Evo, hola, buenos noches to you too, my friend. Are there any components on the bottom of the board? Da, 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 da. Ha! No, there's not. Nice. So that was a pointless exercise then. So I think, if I'm honest, that the amplifier is fine. I don't know what the customer is saying about overheating. I'm not seeing any signs of the amplifier itself overheating. I'm not seeing any signs of the you know, the MOSFETs. Which are actually clamped to the heatsink. He was saying the heatsink was getting pretty hot, but I'm honestly not seeing what components that are attached to the heatsink are getting hot. Let me just put a couple of these screws back in, and I just want to run it on idle again with all of the components that are on the heatsink removed from the heatsink, so I can use my thermal imaging camera and see which ones heat up. Now I do expect the output transistors, the output MOSFETs on this one to get hot on idle, because they are running at 400 kilohertz, which is very, very fast. So I think there will be some switching losses, and I think that they will heat up on idle. I just want to see how much by, and see whether it's plausible for the heatsink to get so hot that it trips into thermal protection mode. So now that we've got those couple of screws in, let's power it back on. Thermal imaging camera in hand. Quad feed, some of that looks burnt. No, this isn't burnt. This has been repaired before on the power supply section. This is just leftover flux. This is just leftover flux from where these MOSFETs were replaced before. I believe this one, I think the customer hooked it up backwards at some point, and those MOSFETs have been replaced. I think he mentioned something like that. Ah! Now actually, interestingly enough, what I can see here in the output section, we actually have different batch MOSFETs used in the same bank. Take a look at this. So this is a B2 Audio Rage series. Now if we take a look at these output MOSFETs, these are one high, one low. And here we have a 31N20D, but we have batch 737P. And over here, not only is this a different batch, but it is completely different font. Wait, come on, focus. It's a completely different font and completely different, you know, engraving style, with a batch P902. Over here, these two are the same batch as each other, which is cool. They should run cool together. Over here, this looks even worse. Look at this. This is completely different batches. So over this side here, We have this one here, which is a batch P929. This one again, another font style entirely, which is a 917. Like completely different font, completely different engraving style, completely different everything. And again, on these last two we have completely different batch as well. Wow, that's interesting. Now I would like to see, fortunately we do have one channel of this amplifier which has the same bank in each, the same batch of MOSFETs in the bank. We have this one here which has RXV1s in both high and low. What I want to see is, I want to see whether the banks that have mismatched MOSFETs in them heat up quicker than the one that has matched MOSFETs in it. If they do, then that is the cause of overheating, which is a manufacturing defect. So let's see, let's power her up then. I mean, I'm still not too happy about these 47Rs getting to 100 degrees, but if I'm honest, I can't see what. I mean, this is very much a brand new amplifier. It's only a few months old, and so this is all going to be absolutely fine. The output section hasn't blown. The only thing that's ever been replaced on this was just the power supply MOSFETs, as it was wired in reverse. So that's completely separate to the output section. The output section regulation circuit has nothing to do with that. So okay, let's power her up and let's see what we can find on the output section then. So here we go. 1.5 amps of idle current draw from the power supply. Let's crank the voltage up a little bit to 12 volts, where we'd be sitting at normally in a vehicle with the engine off, there or thereabouts. Now let's see. We have this transistor heating up here, which is a voltage regulated transistor. That's to be expected. Now the output MOSFETs, despite being different batches, are actually not heating up considerably. So these two here, which are different batches, they appear to be running pretty darn cool, if you ask me. No heat on the screen just yet. It may be that they're still kind of stuck to the heatsink, so that they're not actually showing any of their thermal. Oh no, that is pretty. They are actually away from the heatsink. Let's get them well away from the heatsink so that they can't transfer their thermal energy anywhere. Actually, you know what? This has been repaired in the past. I'm just looking at this now. I'm just looking at signs of like previous repair. This one here, this MOSFET has been replaced. There is signs of solder flux and detinning of this top trace here. Interesting. So this has been repaired before. So now it's anyone's guess. Now it's anyone's guess, like what the issue could be here as to why it's overheating. But I'm not seeing any overheating of the MOSFETs here. Like, it's cranking up to 14 volts now. Got 14 volts on the screen there. Not seeing any excessive heating of the output MOSFETs at all, in fact. But I am still seeing over 110 degrees Celsius on these resistors here. 113, 114. Which is pretty much. Yep, I can even smell them. 125 degrees Celsius now. Now, interestingly enough, oh, okay, the power supply MOSFETs, they are getting cooked. Okay, now that is interesting. Now the power supply MOSFETs are definitely heating up. Okay, so that is a difference now. That is something different that we're seeing now. So now that is where our overheating is coming from. We have over 100 degrees Celsius on the power supply MOSFET, which is very interesting. I would love to know why that is. That must be a change in the drive shape, surely. For a power supply MOSFET to get that hot, like, that is pretty intense, and the current draw from the power supply must be pretty big as well. So let's wait for that to cool down a touch. I'm going to turn the power supply off. We're going to take some isopropyl alcohol, spray it on here to cool it off. Then blow on it to let the isopropyl alcohol evaporate and take some of the heat away with it. Okay, now then, let's take a closer look at the power supply section. Now that we know where that heat is coming from, where the heat on the heatsink is overheating from, let's take a closer look at the power supply section and figure out why that's overheating like it was. So we have 1.8 amps worth of current draw, 2.7 amps worth of current draw now. Wow. Okay. Now that drive wave does not look too pleasant. The current draw is creeping up. We have 3 amps now. How's the thermals looking? Are we back up at over 100? We are cooking up at 70 degrees Celsius and climbing. Let's take another look. We are at 3.2 amps now. This big spike, that's our issue. Big ass spike. And the gate drive does not look that great either. Here we go. The gate resistor values in these are 150 ohms, which is a little high. I'm willing to bet that might be the problem. Now, like I said, this amplifier definitely has been repaired before. And we have different batches of output MOSFETs going on. We have solar flux on the board. And we have IRFP 1405s in the power supply section. So these power supply FETs, these are IRFP 1405s. And they are pretty beefy MOSFETs. And I doubt that they would have been the originals here. I reckon the original MOSFETs in this would have been 064Ns, which are very easy to drive, lightweight MOSFETs used in a great deal of things, actually, using a great deal of amplifiers. But these 1405s, these are a lot more beefy, and they require a lot more gate charge, and they have a lot higher gate capacitance than the 064Ns do. So I reckon that what's happening here is that with a higher voltage, and as things start to warm up, those gate resistor values are just far too high, and those MOSFETs are not able to switch properly. So what I'm going to do first of all, before we do anything else, is I'm going to lower that gate resistor value from 150 ohms to 22 ohms. I'm just going to find my compatible resistors here. And once we've lowered it to 22 ohms, or around about that mark, we're going to power it up again and see if the really, really hot power supply MOSFETs are no longer. That's 47s. That's a bit higher than I want, really. 47s will probably be fine, but I'd like to go down to 22 if I can. Three R3 is a bit low. 22, 29s. $34s. They might do. I might stick some 34s. Unless I can come across my 22s anywhere. No, okay. We're gonna throw some. Take a look at the sizes of these. we are going to throw some, let's put some 47s in, because they're the right size. The 34 ohms are just a little on the smaller side. They're just a bit too small for the pads here. The package size is a bit smaller. It will work. We don't need big resistors for gate resistors, but you know, I want it to look right. And I think 47 should be low enough. That's like, oh, that's over 100 ohms lower than what's currently in there. And what's currently in there was working at first, but then the MOSFETs are getting really, really hot. So we're going to go with 47. Also, with this being a full range amplifier, we want to try and minimize excessive heat. Excessive heat. We want to try and minimize ringing and kind of hard switching kind of spikiness if we can. So a higher value gate resistor will help to prevent super like harsh switching, but should be low enough that the amplifier will operate normally and not overheat these power supply FETs. Okay, let's throw a little flux down. Ready for the new resistors. There's plenty of solder on these pads, and this is a pretty new amplifier anyway. So I don't think we need to reflow those pads at all. We can just throw some flux down and throw the new resistors in place. There we are, perfect. They're going on a treat. Okay, excellent. Now they are fitted. Let's just wait for that to cool down a little bit, and then we're going to power it up again, see if the power supply FETs now stay nice and cool with the lower value gate resistors that they should probably have with these FETs. Okay, that should be good to go now. So let's power her up and let's just check the heat on these MOSFETs now and check the wave shape as well. It's pretty important. Okay, there we go. Thank you, El Fuego, for the 5. Your run of live streaming has been a real holiday treat. Thanks. Oh, I appreciate the tip there, buddy. Thank you. Massively appreciate that. Now, as you can see here, we're at 14.1 volts, and we actually have lower current draw than we did before. We have 1.8 amps, and it was up at 2.3 before. We don't have that big ringing spike on the drain of the power supply MOSFET anymore. The gate drive looks far more acceptable. That's much, much better. So I think that we are going to be good in the hood now. I think that this is going to be pretty good to go. We still have over 100 degrees on those resistors, but you know what? I think that's just how it is. Yeah, I think this is great. I think by now already we would have seen an increase in current draw here, and I would be feeling some heat on these MOSFETs, and they're stone cold still, which is good. So I think that's all it was. I think the gate resistors were too high for the MOSFETs that the technician had replaced. Whatever the originals were, they would have been 064Ns. So 1405's in here. It's probably trying to do the customer a treat there with some slightly better MOSFETs, or maybe it's whatever he had in stock at the time. Just needed these low value gate resistors. That's all it was. which is surprising because if you remember back to a couple of live streams ago, we were looking at some of the other B2 mono amplifiers, the Rage series, the Rage 2501 was it the Riot? I think it was Rage, yeah. Rage 2501, and that had 270 ohm gate resistors. However, the difference there is that it had considerably considerably increased dead time and lowered duty cycle, probably to cater for this this issue here, where having ridiculously high gate resistors causes switching problems and causes the MOSFETs to heat up and all kinds of stuff like that. So I think that the 150 ohm gate resistors could have worked, but I would have needed to change the resistor value on this SG3525 for the dead time control to something, you know, around about the 450 ohm mark to get it up down to about sort of 40% duty cycle, something like that. Alright, well, that needs putting back together. I'm just going to throw a few of these screws in. I'm probably not going to put it all back together just now. We're going to crack on with the next amplifier, I think. Although maybe I should, because what happens is after these live streams, I end the live streams super late, and then I'm going straight to bed, and then the next day I've got all these amps to put back together from the bloody live stream. H1 Nicholas, over 100 degrees on a surface mount resistor is too much. I agree with you there, my friend. I agree with you there. However, that part of the circuit doesn't seem to have ever been touched, repaired, blown. It's yeah, I don't think that there's anything really there that we can do. I imagine that they are all going to do that. The only way to be sure would be to grab another one of these amplifiers and see what the waves and heat look like on that part of the circuit. Yeah, very, very interesting. But at the end of the day, you know, I want this amplifier to be perfect. The customer gave me this amplifier to repair because it was overheating on idle, which we found the cause, and we've repaired that problem. If those 47 ohm resistors are a design flaw and are wrong and are getting too hot, then that's something that, you know, that's like a different issue. That's a different repair bill. That's a different repair issue. So that's something that we need to confirm first. Honestly, in the bottom of my heart, I don't believe that this is a issue with this amplifier. I think that it's a design flaw. I think that all of these amplifiers are going to be exhibiting the same really high temperature on those resistors. Just from what I see going into them and coming out of them, they're dropping a lot of voltage. They have what is it? They have like almost rail voltage to ground on them. So of course they're going to be getting pretty toasty. Engineering Essentials, thank you very much. Appreciate that. Do you ever find wrong stuffed parts? Like as in, do I ever find amps with wrong parts and stuff fitted in them? I have found my fair share of factory errors. Like I would say probably the worst factory error that I ever came across was with a Lanza Opti 500.2, I think it was. So I had a Lanza Opti 500.2 come in once, and one channel worked perfectly fine, but channel 2 had a really nasty output. It was terribly distorted. The outputs got super hot super quickly. The amplifier overheated. It was not a happy bunny at all. I'm pretty sure it killed some of the outputs on that section that was overheating and sounded bad. And when I was repairing it, now a class A, these amps are just very generic basic class ABs, okay? And so I replaced the transistors in the output section, fresh matching batch of transistors, confirmed the drive circuit was absolutely fine. And when I was going to fit them in, I was looking and I was just confirming how many transistors per side I needed. And this, from memory, I think this was 5 NPN transistors and 5 PNP transistors made up one channel. So there was 5 parallel NPNs, 5 parallel PNPs through the emitter resistors, right? And on the good working channel, I was checking everything with my multimeter. I was going through everything, and on the working channel, naturally, we found that not the gate. which one is it? The base, I think it's the base, BCE. I think the bases, which is leg 1, correct me if I'm wrong because I'm super shitty at class ABs, but I think the base, which is pin 1, on the good side, obviously, the 5 parallel NPNs had their bases kind of connected together, and the NPNs had their bases connected together, so you had 5 and 5. On the channel that was bad, you're not going to freaking believe this, but actually on the board traces, okay, had the 5 NPNs plus 1 of the PNPs with continuity. The traces actually, I followed them with my eyes. There was 6 of the bases was connected together, 5 NPNs and 1 PNP, and then 4 of the remaining PNPs were connected by another trace on the bases. So basically that was a major fuck up with the PCB design and printing, and like when I fitted the new parts, they all heated up again. It sounded terrible. So I was like, surely this cannot be right. This was very, very early on in my repair days. I was like, look, these channels are supposed to be identical. This is channel 1, channel 2. This shouldn't be the case. Why would we have the bases of these NPNs connected with one PNP? That doesn't make any sense. So what I did is I cut the trace on the board so that lone PNP was no longer connected to the bases of the NPNs. So I cut that trace, so we just then had 5 NPNs, and I then rerouted that trace to the other trace for the PNPs, and the amp worked beautifully, and is still working to this day, about 2 or 3 or 4 years later. So that's the most insane, like, that's not even just putting the wrong part in, that's the traces. Like, how the hell did that get through quality control? Like, there will have been probably hundreds, if not thousands, of those boards produced. Like, what the hell? How does that even happen? How does that happen? Were none of them tested? Absolutely madness. So yeah, that's the weirdest thing that I've come across in terms of like factory errors and stuff like that. That sweater is magic. Thanks, buddy. Yeah, it's just one of my favorite ones. Good old Zelda Christmas sweater, huh? Would you offer recoding as a service in the future? I did, and kind of do still, to the right people, offer a recone service. The problem with my recone service is that I could only get my hands on Digital Designs parts. So in the UK here, I am still technically was a Digital Designs dealer. So I could get any Digital Designs, you know, products, parts, etc. So I would often offer to rebuild people's subs with Digital Design soft parts, which I did many times. There's many pictures on my BZZZ Facebook page of stuff that I've rebuilt with DD parts to great success. This is bullshit. Alright, it's a good job that we checked this, right? I hate this Mylar tape, right? So bear in mind that all that we did with this amplifier, okay, was we removed it from the case, flipped it upside down, had a look at the back of the board, and then put it back in. In doing so, we appear to have created a short circuit somewhere to the heatsink. Look, I have the probe in the heatsink, and on the drain of this MOSFET we have continuity. These orange tapes for the thermal transfer tape are great because they're nice and thin, but my god, they are very frustrating because they are so thin. The tiniest bit of solder that you can ever imagine will cause this, will short out to the heatsink. And guys, if I power this up now on a high current power supply, the whole thing would go up in smoke. Always check this. I've just got into the habit of doing it. Before you power it up, after you've re-clamped down your clamps, check continuity of the parts of the transistors that are connected to the heatsink. Check for continuity to the heatsink, because as we have here, we have now got a tiny short somewhere to the heatsink. Now I've got to try and find out which one it is that's responsible for it. So it's none of the output FETs. It's none of the output, so it must be the rectifiers then. Do you prefer DD subs over ground zero subs? Yes, I'm not the biggest fan of ground zero in general. I don't really like much of their stuff. Okay, there we go. The short has gone away. So there must be a tiny bit of solder or something, or a tiny metal strand behind these rectifiers. Silpad won't do that. Ah, yes it will. I know from experience. Trust me, I know the hard way that Silpad does do this. Just less. It's less sensitive to this crap, but it does still do it. If you get a big enough piece of junk behind your rectifier, then it does still do it. I can't even see anything. Can't even see. Actually, you know what? Let's zoom in right here. Right? I cannot see a single thing that would be causing that. There's like, I don't know, maybe a tiny dot on this one. What's that? Is that a tiny piece of metal there, maybe? Oh my word, it's not even. What even is that? There's nothing there. That must have been it though. So crazy. Can't even see anything. So let's just smooth this over with my finger. If there was anything there, just to get it out of the way. Absolutely ridiculous. Okay, now let's screw those down. I've wiped them over. Let's screw them back down. And let's check continuity to heatsink once more. So that goes on there. That goes on there. And that goes on there. Let's grab this. Now this is looking somewhat bent, I must say. I did see a very small thing on the back of there, but it's all it takes with this thermal stuff, this tiny thin mylar tape. That's all it takes. Alright, let's try again now. There we go. No more short to heatsink. Hopefully none of the output FETs have it either, so let's do all those back up again now. So yeah, whatever I wiped away then, I didn't even feel anything, but I obviously wiped away whatever it was that was going through the tape. Freaking nightmare. But the amount of times that I have thanked the Lord that I have checked that, like now it's just standard procedure every single time. Whenever I have put the clamps back on the FETs, whether it's screw clamps, whether it's the clip-on clamps, any time that I put anything onto the heatsink, first thing I do straight away, check every single one of these things to see whether there is any shorts to the heatsink. Because you can spend like 6 hours repairing an amplifier and have it all taken away from you by that one moment. You fixed it, it works perfectly out of the heatsink, you feel great about yourself, you've had a good day, you've got this amp up and running, you spent £180 on MOSFETs for this amplifier, power supply FETs like freaking 3006s or something, and output FETs 48s, 68s, and you spent a bunch of money on parts and 6-8 hours of your time getting this freaking thing back up and running. You whack it back in the case, having a good day, give it one last test. Man, that thing blows up in smoke. You wish you checked for heatsink shorts. It can ruin a man's day. Alright, I think we are now good. That's all of the clamps on. So I'll test this, I'll test this out later, just make sure that it's cool. But that was the only issue the customer was complaining about, was that it was overheating on idle, but it did work fine. So I'm gonna see whether I have any other fellow technicians that have any of these amplifiers in at the moment, that I can get them just to confirm for me what waves they have on those 47 ohm resistors and how hot they get. But as far as I'm concerned, that is not something I'm going to look into just now on this amplifier. It's working fine. The issue with the overheating of the power supply FETs was resolved. Yeah, we'll look into it in future if need be, but I think that that's all that was. Reese Carney, very possible, my man, very possible. I actually, when Reese, when you sent me the picture of it back in the case, I was wondering, why has he put it back in the case already? Like, you can just test it outside of the case, and you know, that's the best way to make sure it works before you reassemble it. So I was wondering a little bit then. I was like, why is it back in the case already? What do you think about modifying an alternator to do 15 volts with the 2 diode mod? I don't know much about that. I don't ever mod. I don't ever modify alternators, or I never worked on alternators, so not too sure. So gentlemen, you have a choice. Your next amplifier that I can put on the bench this evening, we can either look at the very, very fun... So I'm going to look at both of them this evening anyway. So both these amps will get looked at this evening, but you get a choice as to what you want to see. Next, I can either look at another B2 audio. I have, up on the bench, up on the racks here, I have a B2 audio 0.5. It's, yeah, B2 audio 0.5. It's a red one, really nice amplifier. Customer claims that the amplifier comes on perfectly fine with the blue light or green light, whatever they have, but there's no audio output. So no smoke, no protect, just no sound. So we can take a look at that one real quick, see why that is outputting no sound. Or we can get the vibe from the other live stream up on the bench, which has the strange power supply switchy sounds going on. And that one is over here, the Vibe Class H, I think it is. So what would you like to see? B205 or the Vibe Class G, Class H thing with the freaking crazy power supply? B2, B2, Vibe, 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 B2, B2, Vibe, B2. Oh wow, super mixed in here. Okay, all of the new comments are Vibe. Yeah. Okay, we'll crack the Vibe out. Henrik saying B2 more than once doesn't count for that. the Vibe is pretty interesting. Yeah, let's take a look at that. Okay, here we go. So I am going to need to first of all update my current amplifier status, which is Vibe Class Z. Because that's what it does. It goes zzz. So, was anybody not with us on the other live stream? Is there anybody that doesn't know what this amplifier is doing at the moment? Because if there's enough people that don't know what it's doing at the moment, I'll show you real quick and I'll power it up. But I'm just going to start removing some of these MOSFET clamps so we can get it out of the case, because it definitely needs to come out the case. There's a lot of shit going on here, I think. Although perhaps not, actually. Perhaps we could keep it in the case just for a minute. Maybe I'll keep it in the case for a minute, actually. I think we might be able to do a top board repair, actually, here. Okay, I think there's enough people that don't know. So let's power this up then. let's power this up. And let's show you guys what it's doing. I need to reconnect a couple of resistors, actually, first. Ian, thank you for the 5, dude. Bevis, props for thinking about current amp status. Shot your DM in Messenger. Okay, cool. I'll check that in a bit. And yeah, I'm trying to stay on top of the current amp status. I'm trying to remember to change it when I change amps. So yeah, cheers for that. Much appreciated. We're out of my tweezers now here. Ah, here they are. I'm just reconnecting these kind of gate resistors here, just so we can show you guys what it's doing. Okay. Actually, there's no point reconnecting that gate resistor, because that gate resistor is open, and that's why I have a jumper wire there. Let me see if I can replace that gate resistor real quick. What is that? That is supposed to be a, I don't know, something low value, 2 ops, 4 ops, fucking something. Okay, so for those of you who weren't here the other night, this is what this amplifier is doing when we attempt to power it up. Plug my power supply wires in. It's very fun to mess around with this one, actually. Very, very fun to mess around with while it's in its current state. Because you can make music with it. You can create... Someone should sample this and we can create a beat with this amplifier. Nicholas, which amplifier prefer you? Which amplifier prefer me? At the moment, I am telling everyone to buy the Taramp Smart 3. Absolutely fantastic circuit in the Taramp Smart 3. Really, really cool little amplifier. Just going to see if I've got another grub screw that's going to fit in here, because this is missing a grub screw and it's the terminals are very corroded. So if the wire isn't making a good connection at all times to the terminal, then it's not going to power up normally. It's going to do all kinds of weird stuff. Weird stuff. Okay, that's ground. Maybe I can just kind of like plug that around here. The terminals are absolutely mutilated on here. They're all melted and burned and freaking... This amplifier is a heap. This is a wreck. Honestly, I don't know how terminals get in this condition. It baffles me. Alphard UK. Hello. Hello, I think Powell, is that you? Powell? Or is it Pavel? Powell? Because the W in like kind of Scandinavian countries is pronounced as a V, right? So it could be, I think maybe it's Pavel or Powell, I don't know. But yes, how's it going? They're on their way. Taramp Smart 3, if that's the case, let me know. They are currently available to buy on eBay. There's a seller in Brazil that I work quite closely with, who ships them over to the UK with free shipping. You do have to pay import charge sometimes though, which sucks. But if Alphard Auto UK are getting those, it's about time. It's been out long enough. Alphard UK, yes. Pavel, how's it going? Good to see you on here, buddy. And they are coming. Good stuff. Good to know. So that means in future, then I'll be routing customers to your shop for some tasty Taramp Smart 3 goodness. Oh, I love it. Right, so hopefully this amp's going to do the same thing that it did the other night. What we have here then, we have a Vibe Class GH. It's called a Class GH, typically Class H. So what this is a Class AB amplifier. However, in addition to having regular BJT transistors on the output section, we also have the addition of two MOSFETs. One MOSFET here and one MOSFET here. And what these do is they will, as the amplifier starts outputting more power, they will begin to switch the rails on and off, and that massively improves the efficiency of the Class AB circuit. It reduces the quality quite considerably. It turns it more into a Class D almost, but it massively improves the efficiency and allows this amplifier to output much more power than it would normally be able to do in regular Class AB mode. So yeah, pair of rail switches here. And here are the standard BJTs over here. Now this amplifier is very interesting and strange in the way that it is designed. So if you take this amplifier, if you ever got this amp on your workbench for the first time, and you read between legs 1 and 3 of the output transistors, as you might normally do, you will see a 22 ohm resistance there, which you might believe is dead outputs. In fact, you would be wrong. That is designed. It is designed to have a 22 ohm resistance between legs 1 and 3 of these outputs here, which is it's less common to see. That's pretty unusual. But it must be just part of how this circuit is designed. You want to go ahead and check the MOSFETs though. They shouldn't have that. The MOSFETs should have a nice high diode reading from 1 to 3. If that's low, then they're dead, but they don't usually die from what I've experienced. So let's power this amp up and show you what she's doing. It's pretty funny. 1 second. MIDI to key, start. There we go. On, and now it decides it wants to work normally. Ah, you should have seen it the other night. It was playing all kinds of games. Thanks, Matthew Macy. Merry Christmas, everyone. 20 days and going strong. Absolutely. I have had a couple of days off, but yeah, still going strong. Why do you want to behave now? Why? I wanted to show everyone what you were doing the other night. It was absolutely hilarious. Okay. But this is still an issue. This is actually still a problem here. So what we have here is we have the power supply section in what appears to be some kind of health check mode. Okay. Now this amplifier uses a PIC. This over here is a PIC. It's a PIC 330F2010. Now this is a programmable chip. So what this is this chip is programmed with some specific firmware, some specific modes of operation over at the factory where this is produced. And it'll have certain functions like protection circuit functions, and it also in this case has a health check mode. So what that means is when the amplifier is first powering up, we, instead of going to full duty cycle straight away, the amplifier goes into a kind of reduced, very small duty cycle mode with a couple of tiny pulses on the MOSFET gates here. As we can see, this is what's being sent to the MOSFET gate at present, tiny little pulses. And that should be building a little bit of rail voltage, which the amplifier PIC should then detect and decide whether the amplifier is ready to go into full operation or not. At the moment, it appears that the amplifier is not allowing it to go into full operation. We have just the very high dead time pulses on the power supply FETs, and we want to take a look at the rails. Okay, because that might tell us a story here. So negative rail we have here at negative 11.7 volts. Positive rail, that's still negative. Positive rail we have at 16.3. So there's a little bit of variance there in the rails. It's not quite equal. There is some funky stuff going on as I apply the remote though, with the low side rail. But yeah, I think maybe the amplifier is not coming on because there is a deviance in the rail voltage here. It could also be that the PIC chip is just dead. Now, I am looking for some pulses. There we go. There's the pulses from the PIC. That's fine. And what do we have on the transformer output? That's what we have on the transformer output. Reese Carney, thanks for the 10, man. Appreciate that. That's really cool of you. Thank you. I'm happy to help you get that Hertz up and running. If you want to give it a go, some more. And Mads Aham Jacobsen, cheers for the 50. I think that's not a Danish kroner. I'm not sure what that is. But thank you very much for those 50s. I'm currently working on a Vibe M14K. I've got the amp working, but when I clamp FETs on, it protects. When you say when you clamp the FETs on, do you mean when you clamp the FETs to the heatsink? Or just when you solder the FETs in? Because the Vibe M14Ks, you know that they obviously come with the soldered heat spreaders on the back of the MOSFETs. I don't know if I've got any here as an example. Yeah, possibly here. So they come with heat spreaders soldered onto the back of the FETs, which are electrically insulating but thermally conductive. And obviously you need to either replace these, like desolder them from the FET here and resolder them to your new FETs, or replace this with some sil pad, for example, or some thermal pad, thermal tape, etc., instead of doing all that soldering nonsense. Yeah, let me know what you are, why it's going into protection there, what it is. But yeah, in the regards then of this amplifier, it seems to just be stuck in kind of health check mode. I haven't come across any dead outputs in this amplifier, because we are building rail voltage still. We are still building rail voltage in this amplifier. Now we're starting to see what we saw the other night. So now we're not getting any life whatsoever. Now we have absolutely nothing coming out of this. So it still has 12 volts going in. Look at the scope screen. We still have, I'll zoom in a little bit on that. We still have 12 volts going in. Actually, you know what? That's really crooked, isn't it? I don't notice my scope screen is straight here, but it's crooked on this screen. Let me just sort that out real quick. Let's go to transform, edit transform, and let's just skew the rotation slightly this way. When's it going to be level? Maybe about there, maybe? Is that about level? Something like that. Yeah, that's probably about right. Maybe a touch more. Oh, no, I'm rotating the main screen now. There we go. Yeah, that's probably about right. Skim that over slightly. There, anyway, as you can see, on the scope screen here, we still have 12 volts going in. We still have remotes going in. And ground is still at 0 volts, which is, obviously means that we don't have a lack of ground connection. But we don't now have any health check mode on the FETs, and we also have no LED here. Now, these amplifiers that use a PIC chip like this problem that we're experiencing here, where we were getting operation in a health check and now we're getting nothing, that is quite a telltale sign of a dead or dying PIC chip. They don't last forever, and as they die, it's very difficult then to repair the amplifier, because you can't just buy replacements of those chips. Yeah, okay, you can buy the chip, but it won't come with the firmware installed on it that the amplifier originally needs. So you can either try and bypass the PIC chip, just try and force the amplifier to come on. Maybe I think in this case, I think the PIC chip itself is generating the pulses for the power supply section, so we need to throw a 494 in there or something, throw some kind of pulse generator in there to get the amplifier to come on. We then have to go through and disable various protection modes and get the output to come on, blah, 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 blah. Bit of a headache. Or you can try and source a replacement PIC chip from a donor board, or if you know someone with a programmer thing with their PC, try and grab a donor PIC chip that works, get them to dump the firmware if they can, if it's not locked or whatever, and then reflash a bunch of fresh blank chips with that firmware. Luckily for me though, in this very, very strange occurrence, I just so happen to have a spare board for these amplifiers. What are the chances? This is not like massively common amplifier. It's like, yeah, okay, there's a few of these floating around, but it's not like the most common amplifier ever. But just as luck would have it, I do have a spare board for these. Here we go. I have a spare board for this amplifier. Very, very interesting. Now, this board is pretty bare, not going to lie. There are a few things missing, a bunch of stuff missing. There's the output transistors are missing there, so we're going to have to get those off the other board. I think the diodes, they're okay, they're a little bit bent. So the power supply is fine. Power supply drivers are fine. The PIC, I believe, also is fine. So all that we need to do then is we just need to replace some of these parts in the output section over here that are missing. Output transistors, one of these switching MOSFETs over here, rail switches is missing, and also the terminals on this one are beyond fucked. Like, the terminals in this one are royally fucked. That is really burnt, and so that one's burned and melted, and this one, it's so rounded off and also fused. Like, you can't get that thread just won't come out of there. So even though the condition of the terminals on this other one is not great either, I'm either going to have to steal the terminals off of this one, which also are pretty terrible, or I'm going to have to try and see if I've got a donor board that has some replacement terminals on it that I can nick. But yeah, that's what we need to do with this one. So guys, would you like me then to probably spend a good part of the next hour disassembling this one, removing the parts from this, transplanting them into this one, and trying to get it up and running? Or instead, would you like me to, now that you have seen what the issue is, I've explained a little bit about them, would you like me to move on to the B205, which has no audio but comes on? That vibe is going to be a bit of a long one, I reckon, like disassembling it, like desoldering, resoldering, blah blah blah. So I can do that for you if that interests you, or we can move on to the B2. Dylan says, sounds like a job for Maisie. My man, Dylan. Yes, absolutely. That sounds like a job for Maisie. Guys, if you haven't already, I'd like you to meet Maisie. Look at that bad boy. This is a 200 watt. Yes, you heard that right. 200 watt soldering iron. Made in the UK. It's made in Horsham, Sussex, England by Weller Electric Limited. Is a W200D, 240 volt, 200 watt, and that will be 200 real British watts. And this soldering iron was last inspected in 1992, merely 1 year after I was born. So when I was 1 year old, or when I was maybe not even 1 year old, but when I was literally like tiny, only just been born, some engineer somewhere in the country was inspecting this soldering iron that I have in my hand for, you know, to make sure it's working fine. And now here it is, some 29 or whatever years later, and we're using it to repair amplifiers. Pretty cool, huh? Old shit, never stops working. Especially just basic stuff like soldering irons, it's just a heating element. B2, y'all want to see the B2? Cool, no worries. Let's put this vibe to one side. Let's crack open the B2, see what we can do there. Ah, yes. 0.5R. Oh, she's heavy. She is not lightweight. Aye. Teacher. Oi. Maybe that camera? Yeah, that'll do. Let's give him a ruby. Let's do some screws here. Now, so customer claims amplifier comes on, however there is no audio output. Now, there's generally two main common reasons for this. If you get an amplifier that appears to power up fine but it's got no output, unless it's a JL audio, because if it's a JL audio that means it's fucked. But if it is anything other than a JL audio, then typically that means that your power supply section is okay, and you either have a preamplifier issue preventing the signal from getting to the output section, which is usually just one of those little toggle switches that has sort of got oxidization built up on the contacts. So you either have a preamp fault, just something preventing the signal from passing. Alternatively, you could have a muting circuit fault, and the output section could not be switching due to it being in mute mode or muted. So yeah, what we're going to do first of all is I think we can power this up because the guy said it powers up fine. So we're going to go straight in and fire her up. Let's have a look inside, shall we? So B205R, 0.5R. We have quad power supplies here. There are 2 FETs per bank push pull, so 2 FETs per side of the transformer, 4 FETs per transformer. Pretty nice. We have auxiliary taps coming off of these for the VCC rails for the chips and op amps and stuff over here. Output section, it is a twin paralleled output section. So it's a half bridge, but we've got 2 separate little mini amplifiers in here. This one here and this one here that then parallel after the filter circuit for the speaker terminals. So each if this was a 5, I think this is about 5k maybe. If this amplifier makes 5k, then each at 1 ohm, each of these amplifiers will make 2.5k at 2 ohm. And then they parallel together after the filtration circuit to give you the 5k at 1 ohm. Yep, we have the VCC aux voltages over here, plus minus 15 volts. And over here we have the 12 volts ref negative rail, pretty generic stuff. We have a dual IRS21844S driver on the back here. Very, very generic. Yeah, a nicely built amplifier, very well seated down, very well assembled, nice parts used, decent caps, etc. Overall, not too shabby. So let's plug some power in and see. The telling tale will be, if we see output switching, then the issue is in the preamp circuit. If we don't see output switching, then the issue is in the muting circuit or the drive circuit. If we see output switching and it makes audio, then it's the customer's fault. He's got another problem somewhere. I got a nice spark there. I don't know if you heard that. Putting the power cables in. So he obviously disconnected. Yeah, obviously it's disconnected with the batteries hooked up. So these power supply caps still had their 12 volts or 14 volts, whatever is chilling in them. Okay, so let's turn the power supply on. Gonna go nice low voltage to start with, 10.7, and I'm gonna let 6 amps into this bad boy. Get it powered up a little quicker than with the 4 amps that I usually go for. And we want to probe low side drain. So the first thing I'm gonna do is just pulse the remote ever so slightly, just to build up like a few volts of rail voltage, and then we can identify where the high and low sides are. So let's probe this bar resistor here. There we go, there's our low rail. So our low side FETs are these ones here, closest to the rail caps, probably the same on this side as well. Yep, that's our low side. So I want to go ahead and probe there, which is going to be the input to this inductor, which we should have the rail to rail switching on when the amplifier is powered up fully. Going to clear message, going to go for volts RMS, frequency number 2, volts RMS. There we go. So yep, here we go then guys, full power up. Ah, okay. Well, there is no rail-to-rail switching there whatsoever. So that would then mean that there is a problem with either the muting circuit or with the drive circuit itself. So when you've got a situation like this where you don't have any switching on the output section, the first thing that you want, there's a few tests which you can do, okay? So in order for switching to be present on the output section, all the MOSFETs are hooked up and everything like that. Like this amplifier worked and then randomly one day didn't. So, you know, nothing, you know, there's not like it's been sort of repaired and then something's happened. So it's going to be something's missing. There's like a voltage missing, or there's a protect mode that's high or something like that. So what we want to do is we want to make sure that the amplifier has, the amplifier's drive circuit has all of the required voltages which it needs to operate. From memory, I think these things need plus minus 15 volts, plus 5 volts at least, sometimes also minus 5 volts, and it needs plus 12 volts referenced to negative rail. So if negative rail is negative 100 volts, it will then need 88 volts on somewhere, one of these pins. So let's power it up again, and let's just go ahead and probe all of these pins on the power supply drive board, and let's see if we have all the voltages that we need to get this thing up and running. Okay, so still no switching, that's great. So let's start probing these pins. I'm going to start with the ones in the middle. These ones in the middle will usually have the lower voltages on them for the PWM generation circuit. So pin 1, we have 0 volts. Pin 2, we have plus 5. So there's our plus 5 that we need. Pin 3 has 0 volts. Pin 4 has 0 volts. Pin 5 has our negative 5 volts that we need. That's great. Pin 6 has some PWM. Okay, that's cool. So the PWM generation circuit is working, so it must be the output drivers that are not working. And pin 7, last but not least, has R plus 12 volts. Okay, great. That is all of the voltages which these need to work on. So now what we're looking for is we're looking for 12 volts reference negative rail. That is the last thing that could be missing, preventing this from working. So our negative rail is 78. So we need, what is it, 78, 68, we need 66 volts. Negative 66 volts on one of these pins over here. So let's go and have a look on this side here. We have negative rail on that one. We have negative rail on that one. Negative rail on that one. There we go. 66.3. Okay, so this amplifier has all of the correct voltages being supplied to the driver card in order to operate normally. But we still don't get any switching. Now, we saw there from the pins in the middle of this driver card, we saw that one of the pins had some pulses on it, which means that this pulse generation circuit is working. These little op amps, this 072C and LM211, they are working fine to generate, to try and build the self-oscillating environment the output section works on. But for whatever reason, these output drivers are not doing anything. I want to just make sure. See, these output drivers here, the IRS21844S, they have an input pin. So they will receive PWM input. The square waves will be fed into these chips. They'll then create high and low side versions of that, which to drive the MOSFETs. So I want to make sure that the input pin, which is pin 1 or in this case, which is just on here, you won't be able to see it because the cameras are absolutely shite, I apologize. But pin number 1 of the RS21844S is input. So I want to make sure that there is some pulses there, reference negative rail. Yes, there is. There are some pulses there, you can see. So the issue then is that the IRS21844S chips must be in shutdown mode. And the reason that they'll be in shutdown mode is due to a faulty protection circuit. So what we need to do is we need to, first of all, replace a few components in the protection circuit itself. And I know exactly which ones to replace. I'm going to try and give you a nice close-up view of these driver cards to show you which ones I'm going to replace, so you know for future reference. Let's try and grab one of the dual, here we go. I think this is one of them. So this is quite a stripped down version because I've obviously stolen quite a few parts from this before. So this is the driver card that is in this amplifier, okay? And these are the IRS21844S chip locations. That pin 1 with the arrow needs to have PWM on it, which it does. Now, from experience with these, the shutdown pin, okay, if that has a specific voltage on it, it'll shut down these chips and prevent them from switching, prevent them from working. And the transistors which normally fail in these, which cause this to not function, are these transistors up here. These are labeled, they're actually called, they have a little writing on them with MAX, M-A-X. I can't remember from the top of my head what the models of these transistors are. But yeah, MAX, and generally these go bad, they start leaking, and then you end up with these chips in shutdown. There's also a 1D and 2D transistor here, which you could replace if you want to. It's not essential. They're not typically the ones that go bad, but I might just in this case just replace most of the semiconductor parts, most of the transistors on the driver board, just because it's a bit strange. You know, this has gone bad. I just want to refresh all of the transistors, all the small SOT23 parts on the driver board, just to kind of maximize the future reliability of this amplifier if they are starting to go bad on this one. Q8 looks janky. Yes, this is not the driver board from this exact amplifier. This is a donor. So this is one that's just taken apart. Q8, where's that? This one? Yeah, that looks like it's been replaced before, doesn't it? Or looks like it's all sideways. So what I'll do is I do have loads and loads of these driver boards. So I'm going to pick one to take our replacement parts from. So I need 2 of those MAX. Here we go. I have a spare driver board here that never gets used for anything else. This is a slightly different size one, this. See this? Now this isn't your typical long boy quad, this is a kind of short stumpy boy quad, and this does have 2 of the MAX transistors on it, which I need, so I'm going to steal those from there. And then we're going to put some new 2Ds and 1Ds on there as well, just for good measure. So let's keep that safe. 1. And 2. There we go. Eberg amplifier repair, KTD 1304. Ah, good to know. KTD 1304. That's the part number of those transistors, apparently. I couldn't remember off the top of my head what they were. But we've got a few donors, so that's all good. Now, obviously this amplifier doesn't need full disassembly. You know, the amplifier itself, the MOSFETs, etc., all absolutely fine. The only issue is on this driver board here. So, I think I see the cause. It might not even be those transistors, you know. I've just spotted something in here. I want you to take a peek at the board here. I want to see if you can see what I see. It looks like we have a little bit of vibration damage, which is very interesting. Looks like it might have been replaced before. Here we have a K30. I think this could be some type of JFET or something. Now that leg is definitely snapped. The leg of that JFET is definitely snapped. So the first thing that I want to do then, obviously, is just quickly solder that back in place. I'll probably replace that K30 anyway. It might be a transistor. Some of these amps use a JFET there. Some of them use a transistor. Can't remember what K30 is. Someone can look that up for me now if they like. K30, is that a JFET or a transistor? But maybe that's all that's needed. And I do have some spare K30s that I can replace with, if needed. But let's just solder it back in place. And let's see whether that actually brings our amp back to life. Just going to make sure it's not shorted first. 210. 210. That's a touch low, perhaps. 210. That's a touch lower than I'm perhaps used to seeing. Let me grab another one. Let me grab another K30. Got another one in here? J1111. There we go. Here's a spare K30. So I'm actually just going to go ahead and remove this K30 from this board just to read it on the transistor tester. I want to just confirm that it's fine before I go soldering it back in. What's the static on the mic? I think it could have been my soldering station cooling down. Okay, this reads as an N-FET. NJFET, there we go. N-channel JFET. Yeah, I was right, it is a JFET. Is that even going to show up? Do a focus, come on. You know you want to. You know you want to focus on this thing. No, it doesn't want to focus, but whatever. It's, yeah, JFET. And I think from memory, the JFETs do have pretty low resistance, 1 to 3. This one has 620. but it will change, I think, depending on what state this JFET is in. You know, how kind of turned on it is. Sounds a bit wrong, doesn't it? But let's remove the one that's in the board here first, just quickly. Let's make sure that there's no rail voltage still sitting on it. It hasn't pulled down yet. Don't want to get a spark on my soldering iron. Let's pull that out the board. Okay, the leg wasn't actually snapped. That's funny. It just looked like it was snapped. Did anyone else like see that it was snapped on the camera? It really looked like it was snapped, but I think it must have just been the solder. Yeah, this still reads as an NJFET, so that's actually fine. Okay, cool. No worries. It must be then my original thought on the driver board. I think what I do want to do though is I do just want to check some of the other components around that transistor. So that K30, that is what's known as the muting transistor. So that is going to be responsible for sending the output drivers into shutdown mode, which is what they are currently in. So that is what's normally supposed to be responsible for shutting down the drive ICs. And the reason that that's there is it holds the drive ICs, the RS21844S, in shutdown mode for a moment while the amplifier powers up, and it only releases them into full operation when the amplifier is ready to come on. So it kind of acts like a slightly delayed start, a bit like a slightly soft start, so the transistors there, so the drivers there don't just turn on straight away as soon as they can, which is it can cause problems if the generation circuit isn't powered up already. So now that I've just soldered that back in, I just want to power it up and see if that has made any difference. I want to see whether perhaps there was a bad solder joint there or something that might be preventing that from coming on originally. So let's plug our wires back in. I don't think it's made any difference. I think it's still going to be not working, but I just want to see. Oh, hey! It came on. Strange. Okay. So, alright, maybe. I'm a bit concerned now. That's a bit worrying. As I haven't done anything. All I've done is reflow that joint there, and I don't think that joint was bad. I think this could be turning into one of these really annoying ones. So, in the past, I have had these amplifiers with this type of muting circuit that are very intermittent. So what happens is they get kind of latched into muting mode, and no amount of replacing the JFET, no amount of replacing parts here, there, whatever, ever seems to really bring them back to just working all the time. Like, they work for a few months, and then they'll get stuck in that shutdown mode, in that muting mode, and then removing and replacing the K30 like sorts it out, and then it works for a bit, and then it will just randomly mute itself again. No, this isn't another shorted inductor, luckily, but it definitely didn't look right. But I have had enough experience with these freaking ones, with these ones that are muting and then they're not, and they're muting and they're not. I've had enough experience with these ones to know that this could be a bit of a pain in the freaking arse, because this is going to work fine for me now, but I think if I give this back to the customer a few weeks later, it's going to be doing the same thing again. Okay, works every time now, I bet you. Most people are thinking it's a bad solder joint. Yeah, I don't... it didn't look great, I'm not going to lie, but I'm not convinced, because I've seen this before, and I think this is going to be one of these ones that just becomes a nightmare. In a few cases, I've actually ended up having to, with some of these amplifiers, like the best, cheapest solution was just to jump over the muting circuit transistor there, just so that it's always operational. If I'm honest, there's not really a lot of need for this circuit. Like, this muting circuit here is kind of redundant. It doesn't help the amplifier go into protect. All it does is it just controls the shutdown mode of the 21844S. But that's not really needed, because when the amplifier goes into protection, they all turn off anyway, because they're no longer being fed with 12 volts or 5 volts or anything from the power supply. So it doesn't really do much. And in the past, I have just disabled, like I've just bridged over the pins on these K30s before, just to get it, working. The amp works fine, and no problem at all. So I think what I'll do is I'll leave it for now. We'll assume that it was a bad solder joint for the time being, but I'll keep this here for a few days, and I'll power it up a few times a day, and see if anything changes. Let's give it 14 volts. So I'm at 10.7. Let's go up. Let's give it 14.4. Let's give it the full 20 amps that this supply can provide. Let's power it up again. Just make sure that it comes on. Bing. There we go. Straight away, first time. Technical specialist. Yes, the function of the JFET is just to, like, yes, it is the muting circuit, but it never gets used exclusively. Like, there's never a situation where the amplifier will go into just a muted mode but not protect, which is why that when it does happen, it's a problem. It's not supposed to do it. There isn't a protection mode where that circuit will activate, but that also won't activate the main protection circuit that shuts down the whole power supply section. It's pointless. I don't understand why it's there. It's really pointless. The only thing I can think of is that it adds a slight delay to the drive ICs turning on. If we see here, you might notice when we do power the amplifier up, look, if we power the amplifier up here, I'll give you both probes so you can see. But if I probe the rail voltage here on the second probe, okay, so monitor the rail voltage here. If that muting circuit wasn't there, then the output section would start switching immediately as soon as the circuit received the correct VCC voltages on the PWM generation circuit. It would just start switching immediately. But this muting circuit adds a slight delay to that, and that's probably thanks to a couple of the capacitors around here, like near to the muting transistor. But if we watch how this rail voltage builds and watch how it then comes on. Okay, check this. Down, full rail, then there's a short delay period where the amplifier delays and then starts switching. So that's what it does. It adds a small delay to output switching from starting. So by disabling that, the output switching enables immediately as soon as it possibly can, which most amplifiers, a lot of them just do that anyway. So it's not a problem to do that. It is better to wait until everything is ready, all the voltages are stable, the rail voltage is built. It is better to do that. So I would rather leave it there if I can. So what I'm going to do for now, I'm going to just turn it off. I'm going to put it to one side. I'm going to put the back on the amplifier and just put the screws in a little bag. And I will come back to this and turn it on a few times every day and monitor it. Technical specialist to prevent the pop at turn on. No, it's not. It's nothing to do with the pop at turn on, because there will still be a pop at turn on if the speakers were connected directly to the FETs when the switching activates. The thing that prevents the pop at turn on is the relay circuit. There's a relay that's in line with the speaker terminals, and that relay only activates after the Class D switching has begun. That prevents the pop on turn on. I think what this muting circuit actually prevents is it prevents a spike to the output MOSFETs that can happen sometimes when the drive ICs turn on before the PWM generation circuit. And I've covered that in previous videos where I've shown you how to correct for that when amplifiers actually do exhibit that issue. I've shown how to correct that. So I think that's probably what its main purpose is, but yeah. So let's put this back for now. Take my hat off so it doesn't pull my neck. Okay, where are we at now then? So yeah, what's left there? I can start working on the vibe. I've got a little bit of time left. I'm not going to go to bed too late this evening. Got a bit of time left. We can start putting the vibe apart and start doing that. Alternatively, is there anything else I can do that's interesting? I've got B2 Riot. No, I've got a Rage 2500. Just needs a new power supply fetch. Pretty easy. All the other amps that I've got that I could show you to work on are pretty involved. Like they're ones that I've kind of thrown to the back burner for now because a while ago because I couldn't be asked with them, and they're ones that I want to do on a live stream for you. But what I will do is I will wait and I'll start the live stream with them because we're 2 hours in now, and I would rather because they're going to take probably like 4 or 5 hours to go through entirely. So I'd rather start with that. Jess and L, love the vids. Thanks, buddy. Thank you very much. Maybe we could do either some Q&A or another idea is that we could look through some of my very embarrassing, very old videos on YouTube that are all unlisted now, and we could have a look at some of the stuff that I was up to when I was first getting into subs and bass. And we could have a laugh at some of the stuff that I got wrong. How's the car? Not sure yet. Not too sure yet. We'll have to wait and see. The guy's doing a few stuff first. Yeah, I can either crack open the vibe, start working through that, or we can go through some old videos or do some Q&A. Maisie needs a trial. Or does anybody want to see what Maisie's capable of doing? Should we see what she's got? Should we take like a donor board and see what we can, how quickly we can solder some terminals and shit. Actually, I'll tell you one thing I do need to do. One thing I do need to do is I need to remove the terminals off of this Vibe donor board. So should we just do that with Maisie real quick? Let's get Maisie fired up. And let's remove the terminals from this Vibe board real quick. And let's see whether she's any good, because I haven't actually used her yet. I used her a little bit the other day. Yep, starting to get pretty toasty already. So now this is one soldering iron you do not want to leave on by accident overnight. Like, how many technicians here in the live chat, put your hand up if you've accidentally left your soldering iron turned on for, you know, overnight, or like while you've gone out. I mean, this will be fine. Like, it'll never die. But drawing 200 watts from your mains socket continuously, do you really want that kind of electrical bill? I sure as hell don't. So yeah, definitely not one that you want to leave on by accident. It's starting to cook up already. Will it take solder yet? Let's see if it will take solder yet. So it won't take solder on the tip, but it does melt solder on where the obviously the heating element. The heating element obviously is all the way up here. So it is melting solder already up at the heating element. We just got to wait for that to sink down to the tip down here. My soldering iron has a sensor and shutdown if you don't move it for 10 minutes. That's a pretty good feature. I would like that on mine. That would be a really great feature. Good day, Davo. How's it going, buddy? Rob C. Sam, if it's like mine, turn off the lights when it's fully up to temperature. Check out the glow. I don't think it glows. I don't think this one glows. I don't think it gets that hot. I wonder whether my thermal imaging camera has the ability to actually read it. Should we see how hot it gets? So it's not up to temperature just yet. Elliot, yes, it's not a 1K like you found for sure. Let's see. I don't know if I'll need to change the scale on my thermal imaging camera so it'll read it. It might be too hot for it. Let's see. Has this got a scale on it? Background temperature, Celsius. Room temperature. Okay, what does it say? It says over. It, like, the max at the bottom just says over. Yeah, it's too hot. So it's, I think that must be over 400. Let's go to the slightly cooler bit. Look, if we go to the slightly cooler bit. How high does this meter read? Okay, I think this only reads up to 320. So whatever it is, it's way over 320. Like, considerably over 320. So, how about now then? Oh yes, that's cooking up nicely now. Yep, that's working a treat now. Alright. That's definitely very freaking hot now. It's quite scary actually wielding this. Like, this is a lot of heat. This is definitely hand burning, like you know, stage 3 burns like in no time if you're not careful, if you touch it by accident or something. Alright, let's see then. Let's get some solder cooked up. So what we want to do is try and remove this all in one go. I want to get a lot of solder pulled up between these 3 contacts here, so I can try and just sort of lift it out all in one go. So I'm going to end up using a lot of solder for this. And these pads are pretty high thermal mass, not going to lie. Let's see how we get on, shall we? I want to try and get some good contact surface area with the board, because I need to get the board heated. Now, I'm not preheating the board for this. Like, this would be made a lot easier if I just preheated the board a little. But I'm not going to cheat. I'm just going to see what it's got. See whether it can do it on like a, you know, a room temperature stone cold board. There we go. That's actually pretty crazy. That is now cooked. That's properly cooked up those four terminals there, pretty quickly. That's pretty impressive. Way quicker than I could ever do with my AOUA station. Let's do these 4 over here. See how long that takes. So I imagine this kind of soldering iron would be used for plumbing, probably for soldering like copper pipes. The biggest soldering irons that I tend to see are for soldering copper pipes together. That's cooking that up pretty good. There's definitely a lot of thermal mass in this iron here. It's pretty quick to reheat it as well. So what I want to try and do then is I want to try and walk this out. Hey, now walk it out, walk it out, walk it out. Let's get the remote one cooked up as well. That shouldn't take as long. It's much, much smaller. Okay, so now if we take my pliers here, see if we can walk it out. So I want to try and connect to the remote tab at the same time as this power tab over here. We're going to have to kind of go backwards and forwards here a few times. And we're going to have to walk it out. I don't think I can get all three at the same time. Maybe I can, you know. Maybe there is enough. Oh, there is. This is going to be awesome. If I just go backwards and forwards across these, that is crazy hot. That is excellent. That is crazy. All right, give this about another minute or so. That should drop right out. Come on. I imagine there's still a fair bit of solder on the top of here, so we're just getting the heat evenly distributed between these three, and this should just drop out in any moment now. Yeah, it's coming. Okay, yeah, the ground one, it's off. Here we go. Here it comes. Here it comes. Come on, baby. There we go. Look at that. Not too shabby. Not too shabby. And it even hasn't melted the plastic. Like, okay, this plastic is melted, but that was due to the terminal heating up from a poor connection on the wire. You can see there. That's why that's melted. But actually, it hasn't melted the plastic, so the heat was concentrated. That is freaking epic. Nice. That has massively sped up my work process. So now we can suck these holes while there's still some heat in the board. Prevent that from cooling down too quickly. Get the solder out of these holes, ready for our new terminal that we're going to drop in at some point. Yeah, so a few of you guys wanted me to turn the lights off and see if it glows. So yeah, I'll do that in a sec. Let me just get this sucked out here. Maisie is sucking, guys. No, actually, no, she's not. Maisie's not. This soldering, this desoldering pump. Okay, awesome. I am dead impressed with that. That is absolutely sick. Okay, so let's what I'm going to do now is go and grab go and turn the lights off real quick. I'm fucking terrified of this thing. It's like a lightsaber. It's so hot. All right, I'm going to go and turn the lights off and let's see if it glows then, shall we? Okay, is it glowing? I would say no. No, it's not. Not glowing. I'm surprised you can actually even still see a bit of my face there. Yeah, not glowing, guys. Sorry. Oh, let's unplug that beast before we drain any more of our electricity. Did the board not burn? No. No, the board is obviously designed to take that kind of heat because it takes that kind of heat when it's made, you know, when the stuff's soldered in the first place. If we just, so I'll show you the condition of the board now. I'm just going to scratch off any of the flux and then take some isopropyl alcohol to it just to clean it up, and you'll see how cleanly it came out. Actually, you know what? There's actually still a tiny bit of solder left in there. I'm just going to get that out. A tiny bit of solder left in that top one. Where is it? This one here? Yeah. Yeah, whatever. I'll get it later. I'm not even sure where my isopropyl alcohol's got now, actually, so I might just show you with the flux. Yeah, so there's bear in mind there's a bunch of flux on the board here, as well. But yeah, that's the terminals now, ready for the pads, ready for new ones, ready for new terminals. Board's not burned, perfect. Just need to get some isopropyl on there, get rid of the old solder flux. Need to suck this hole a bit more. There's still a bit of excess solder in that one. Yeah, not too shabby. Has my standard tips come yet? Yes, fortunately I did manage to get a tip from overseas. Had to go and order one from Europe, so it took a little longer to come, but it did arrive. Okay, so it's actually, what is it now, 10:42. It's quite early for me. Sometimes I would even start a live stream at this time, but I'm trying to get to bed a bit earlier these days. Like, it's not really doing me too great. Going to bed at like 3 in the morning, waking up at like 1 p.m. It's not really doing me too great. So I'm gonna lock off the stream here, guys, and we're gonna continue similar time tomorrow, I think. Wait, what is it tomorrow? Tomorrow is Monday. Yeah, we're gonna do another live stream, similar kind of time tomorrow, I think. And ooh, yep, that's pretty hot. Whew. And yeah, tomorrow, what should we do tomorrow? We could do the vibe tomorrow. We could start the vibe. I'll try and get the vibe disassembled from at the start of the you know, in daytime, so that it's fully disassembled for the live stream, so we can start chopping parts around and get it up and running. But yeah, I think that's it. Unless you guys have got any questions before I go. Watch hella old videos on the last day of streams. That's a great idea, Tiamo. So yeah, probably what we'll do is on the 23rd, or I don't know if I'm going to stream on Christmas Eve, you know. I might prepare a video for you on Christmas Eve, like for Christmas Eve, that I'll upload, perhaps. But yeah, I don't know if I'm going to do any live streaming on Christmas Eve, so I'll probably do the last live stream will probably be on the 23rd, which is actually, fuck, that's 3 days. This is 20, so we've got 21, 22, so we've got 2 more days of normal live streams, gentlemen and ladies, before we do the last one. Can we add a new mod to the DB 1.3, such as better protection circuit, technical specialist? Not really. Nah, the protection circuit, I mean, what can you do? You got DC offset protection, so when there's DC at the speaker terminals, you protect against that, already there. You got overcurrent protection, which is using shunt resistors, already there. You've got over voltage protection, already there. Under voltage protection, already there. That's pretty much it. I don't think it's got any reverse polarity protection, so we could add that. We could add reverse polarity protection, but if I'm honest, there's not really much else we could protect against, really. Saw an amplifier you looked at recently that had 2 TL494s. How they operate? All that is just a TL494 for each transformer. So rather than the power supply, so it had 2 transformers, but rather than the 2 transformers using the same pulses from a single 494, they just used 2. I don't quite know why, but it's a really, really old amplifier. It's a bit like a dual mono. So if you've got an amplifier that's a dual mono, it might have two TL494s. This was a mono. It's not a 2-channel, by the way. It is a mono amplifier, but for some reason it has a power supply setup that's a bit like a dual mono. Quicker response protection. Not really. It's pretty instant. Like, you're never really going to protect against the guy who shorts out his speaker terminals with the gain at full, because the MOSFET is the first thing in line. Like, there isn't enough time for the voltage drop to build on the shunt resistor, and then, you know, for the power supply to shut down. By the time that's happening, the voltage has already shot through the MOSFET. Like, the current has already been drained through the MOSFET, and the rail capacitors are already shorting all of their current down through the MOSFET. So it's really, really difficult to protect against stuff like that. The only way to protect against stuff like that is to have something physical, perhaps in line with the MOSFET and the speaker terminal, that will fail first. So what you want to create, if you want to protect against someone shorting out the speaker terminals, the only way to protect against that is to create a weaker link in line with the MOSFETs that will go first. So normally the MOSFET is the weakest thing. When you short out the speaker terminals, obviously the MOSFET's there, that's the weakest thing, that will go first. You could potentially add a quick blow fuse in series with the output inductor and the speaker terminal, and what that would do is that when the speaker terminals were shorted, hopefully the fuse would blow first before the MOSFETs, but I reckon that would be a guessing game anyway, either way. Why am I so blown out? Is it because I turned the lights off? I'm super blown out with the camera here, and I can't change my camera settings, because if I try and change my camera settings on this, it blue screens. Yeah, the PC blue screens if I try and change my camera settings. DDM4, what do you think? It's a generic circuit design, but it's pretty well built. They're okay. There's much better things you can get now, though. Oh, the lights behind me are off. Oh, that's what it is. Yes, that's why. Thank you. Well observed, Elliot. Just quickly, so next live will be tomorrow. I'm doing a live stream every single day in December up to the 23rd. I want Christmas Eve with my family, not my friends. Can't have Christmas Eve with my friends anymore because we're in tier 4 lockdown now, so I can't do fuck all apart from stay at home. So I'm going to spend Christmas Eve with my family, I think. And but gentlemen and ladies, if you've been enjoying the live streams, then I'm going to make this a thing where we do live streams far more often than I have been doing leading up to December. So I've been slacking off a bit because I've been so busy with so many amps coming in, and it takes me a lot longer to obviously work when I'm live streaming because I'm talking through everything I'm doing. So but all the while that the work remains at its current state in it's not too heavy at the moment. Probably what I'll do is I'll try and do 1 or 2 live streams a week. How about that? I'll try and set a day, like a regular day or time that I'll do live streams, just so that, you know, you can, if you really want to see it, you can kind of plan for it or make time or whatever, if you care that much. Or, you know, I'll just go live when I feel like it. I'll try and throw out like a live stream reminder a few hours beforehand, like I've been doing with these ones. But yeah, we'll try and keep these more regular going into 2021. Have you got a soldering station recommendation that won't break the bank? I mean, honestly, my AOA station has done me fine. It's cheap and it's not great, not gonna lie. The tips are expensive. They're like £15 every time one goes, and they go quite often. I wouldn't say I recommend it, but it does me okay. Soldering iron, it's pretty simple. It's go for a used soldering iron. Older ones tend to be better. Get like an antique. Get an old ass soldering iron that's like 80 watts or at least 80 watts. Try and get at least 60 to 80 watts. Maybe get something old as fuck. that's just going to be reliable, cheap tips, and just works. It's powerful, you know. Give us a demo of your system next stream. Ha! That's something I could do. Hey guys, I went for a drive, what was it, a couple of days ago. One of my amps went into Protect in the bass van. And so, fortunately, knowing what I know, I knew not to power cycle the amp. The amps weren't hot. One of the amps just went into protection mode. They're strapped, and the other amp was still on. So I had Master in Protect, and Slave was still running. And from my experience with this, I knew that the worst thing I could do was turn the amps off and turn them back on again. Because if one output MOSFET has decided to give up, then if I power cycle it, it's going to kill the fucking power supply. So I think actually possibly what we'll do tomorrow then is tomorrow I will pull off one of my amps from the van, and because I want to obviously need to repair it, see what's up with it. I'll pull one of the amps off the van, and maybe we'll look at that in tomorrow's live stream. No, I'm running the amps at 0.25. It's not, no, you know, I've been running the amps at 0.25 for 2.5 years now, and I don't really full tilt the system anywhere. Like, when I'm listening to the system, it will be just ticking over, like barely any power. I don't need them at 0.5, but that's just how 0.25, sorry. That's just how they've been. Yeah, because the reason I'm able to run the amps at 0.25 is, firstly, I've done modifications to them to make them more stable at 0.25. Secondly, I'm running DDZ4s. Now, the DDZ4, Z4 15s, their impedance rise is fucking through the roof. So I can get away with 0.25 with the small modifications that I've made to the amplifiers, and it is lovely. The amplifiers generally run pretty cool. The amplifier went into Protect the other day. I was just out for a cruise drive, and I had the music turned down to a point where I was having a very comfortable conversation with my passenger. It was just super low volume. The amp just turned off, went into Protect. So I think that, you know, MOSFET just randomly failed. I don't think it's got anything to do with 0.25. Yeah, we can look at that tomorrow if you like. Ken has a 400 watt soldering iron for terminal blocks. Yes, I can see why. They're very handy. Tiamo, no, it was not full tilt. Like I say, it was like turned right down, like to lower than listen. You know, I was just literally cruising along with some background music. So just clicked into Protect randomly. So we have a look at that tomorrow. I'll pull the amp off the van tomorrow, and we'll have a look, see what's going on. I might give the second one a health check as well. I'll pull both of them off, and we'll just check them out, see what's going on inside. But yeah, guys. The amps that I have are LW Audio. They are just kind of generic Korean. They're Xenon boards actually. LW Audio 1.4500. Here we go. I'll show you what amps I have. They're these bad boys. There we go. There's a generic board in there. Bloody good boards though. These, like, yeah, it's a generic Xenon amplifier circuit design, but very, very reliable. Like, honestly, these have been so solid. So many people have been running these down at 0.5, and they've been absolutely fantastic. Now, I think now, looking back at these amplifiers, one of the reasons that they are so reliable is this. So the power supply section consists of lots of separate smaller transformers. Now, this has actually been proven to be more reliable than having smaller numbers of larger transformers. So having 6 small transformers instead of 2 big ones is good for reliability and good for headroom. That's been proven. Each transformer only has 1 push and 1 pull MOSFET per transformer, meaning that you haven't got MOSFETs running in parallel banks, which is great. That's fantastic. The output section, we have output MOSFETs, which they have loads and loads of voltage headroom. So this is only a 4.5K amplifier, which could definitely get away with using 300 volt FETs. But in this amplifier, we have FDA 24N40Fs, which are 400 volt MOSFETs, which means that these MOSFETs are run well below their voltage breakdown point, which does improve reliability. They won't be stressed anywhere near as much as if we were using 300 volt FETs switching rail to rail, so that's pretty cool as well. Additionally, the output section here, the drive circuit, this is using IRS 21844S, however, they are buffered by onboard separate buffer drive transistors, which means that the IRS21844S chips are not put under the same stress as they are in many other similar circuit designs that use the drive ICs to drive the MOSFETs directly. So by having buffers in series with the MOSFETs allows those drive ICs to run much cooler and last much longer. The build quality is pretty good. We've got screws all down the middle. The heatsink size is very large for the number of MOSFETs we have. We're using 1405s in the power supply, so which are pretty beefy FETs. They're not 064Ns like you normally see. So we've got beefy power supply FETs. We've got a high number of high voltage output FETs, so they're all running well within their limits. We've got buffered drive circuit, we've got transformers and inductors seated down nicely, a decent filtration circuit. It's just overall a really nicely designed, well put together amplifier that is very reliable. So yeah, really nice things, these. Is the JL500/1 also a full bridge design? Yes, Audio Joe, it is. The JL Audio, all the JL Audio Slash series are full bridge amplifiers. Thomas Marshall, it is a full bridge amp, unfortunately, my man. John Smith, thank you from AL. Can't remember what that stands for. Alabama, maybe? I have never touched a Raspberry Pi circuit board. I've eaten Raspberry Pi. It's delicious. Hi from Minnesota. And seems like I missed most of the stream. Yeah, we're just about to look off the stream, unfortunately. Josh, sorry about that. Thomas, yes, it is. So the JL Audio Slash series, the 500/1, 1000/1, 600/1, 1200, all of those ones, they only use a single rail voltage, so they only have positive rail. Okay, there's no negative rail voltage, it's just positive rail. And that means that on the speaker terminals, both positive and negative, you will find half rail voltage referenced to ground. So if you use your multimeter and you probe the positive or negative speaker terminal, either of them, and the other probe on the ground terminal, the amplifier, the main ground, you'll find that you have about, I don't know, 50 or 60 volts there between the two. And that's because there's only one rail voltage, only positive rail voltage, so obviously the sine wave needs to swing between 2 points. So on most amplifiers, what you'll have is you'll have ground at 0 volts, then you'll have negative rail and positive rail, and the sine wave swings between ground, positive rail, negative rail, with ground being 0 volts. But in a single-ended amplifier that only has positive rail voltage, what you get is you have one positive rail, and then the sine wave swings between a generated mid-rail point, which if this rail was 100 volts would be 50 volts. So the sine wave, as far as the speaker is concerned, this is ground here at 50 volts. 50 volts is ground for the speaker. And then the sine wave swings up to 100 volts and down to 0 volts. And in the case of the JL Audio 500/1 and 1000/1, on both positive and negative speaker terminal, you have a sine wave out of phase with each other, like full bridge. It is full bridge. So the speaker terminals are doing this push-pull with the subwoofer. So rather than in a half bridge having negative speaker terminal being ground and positive speaker terminal doing this with the speaker, in a full bridge amplifier in the JL Audios you have this. You have both terminals working in push-pull to drive the speaker. What do you think of the in-phase 5000D amps? Nah, not great, my friend, not great. Very poor build quality. The circuit design is generic. It's alright. It's not the best components used. The build quality is just not great though. But yeah, guys, thanks for joining. I will see you tomorrow with my my LW audio amp from the van, and we're going to see what's up with that. See if there's any problems, because I don't want to power it up in the van because it could smoke the power supply section if there's an issue. So I'm going to bring it in the workshop. We're going to have a look at it together, see if there is any dead parts in there, and then talk you through the circuit design and yeah, what's up with that. What happened with those subs you built 4 years ago? Which subs? Can't remember which ones they were. But yeah, thanks guys. See you tomorrow. It's been